Dr. James Marsden has recently completed his Ph.D. in astrophysics at the University of Oxford, with a thesis titled Novel Effects in Field Accretion Around Black Holes. His research focuses on dark matter and black holes, and he previously earned a combined bachelor's and master's in astrophysics from the University College London. He enjoys traveling and performing in theatre productions and plays. So, hello, how are you today?
I'm very good. It's a little bit rainy outside, so it's nice we're in this nice studio. So, very glad to be here.
Thank you. So, should we start?
Perfect.
Do you think AI will replace certain roles in astrophysics, or will it create new opportunities?
It's a good question because it's kind of how we use technology, right, in sort of research. So, what I always think of, it's a tool, and to use the tool, you need someone to actually operate it, right? So I think I'm cautiously optimistic. I think that it will be a very good way to kind of increase the productivity that one person can achieve. And therefore we can ask and kind of answer more difficult questions with, not just the same amount of people, but more people can get involved, right? With kind of this easier sort of accessibility into these problems, with the kind of the streamlining of many sort of tedious processes. So the thing I always think of is in kind of the olden days of computer simulation with astrophysics, for example. There's this very famous image of one of the first images of a simulated black hole. This was not even done on a computer screen. They actually printed out this bit of paper, and the scientist took a pen and put every single dot in the correct place, and it creates this beautiful image. But you imagine how long this must have taken, right?
Yeah.
And so I view kind of AI as something which can streamline a lot of this sort of difficult, a lot of time tedious work, and allow you to kind of get to the heart of what I think sort of research is, which is the thinking. Because AI is very good, it's a very good tool, but it cannot replace human thinking and creativity, right? And so it's important to know how to use it so that we know how to, use it effectively, but also use it to increase our own creativity, right? And so by not just using it in a way which we kind of waste its opportunity, right? And not just using it for kind of these menial sort of uninteresting problems. It's about going, right, well, we are these creative, amazing people. And so how can we kind of use this as a force multiplier, like a lever, like a fulcrum. And with this kind of increasing technology, it's becoming more and more sort of accessible to do these incredibly difficult things with sort of fewer people, which then means that, if we get even more interested scientists, get more people excited, through the educational opportunities which AI can potentially provide, and things, with our increasing world of multimedia and things like that, it can hopefully inspire more people through, increased opportunity to do things like astrophysics and science. And then using tools like this will then sort of have like a knock-on effect, right? It becomes easier to inspire people, then easier to work. And again, filter out everything back just so that we get as much as possible into being creative problem solvers and thinking about the physics and the philosophy of things, instead of going, I have to plot all of this data on a piece of paper, which is going to take me all day. And it's not what I want to be doing, the thinking, the enjoyable part. So I'm optimistic.
How do you think astrophysics contributes to solving practical global challenges such as like energy, climate change, communication technologies, all of these big issues that exist today?
Sometimes I always find it's a little bit tricky to answer, but I always kind of think you can do it in both a direct way and indirectly. So what I mean by a direct way is, I guess, when it's called climate change and green energy, you think, well, one of the main forms is solar power, and so the sun is a star, and so if we understand how stars operate and work, which is a huge topic in astrophysics, we can then sort of more efficiently harness solar power and build better solar panels in that kind of sense. Then you kind of get into the more indirect things. So with climate change and climate change modeling, a really big aspect of it is trying to predict what's going to happen to the climate and to weather systems. And weather systems are notoriously tricky to actually simulate. As I'm from the UK, and so I think I have a little bit of authority with saying that basically the weather forecast is always wrong in the UK. We have a lot of ways to go. But for example, what I personally do in my research is sort of doing simulations of black holes. And if you kind of break down, we ignore the fact that it's a simulation of a black hole. It's just this software for simulating, in this case, a field or a fluid or something. And you can adapt this, with a bit of effort into kind of completely different fields. So, for example, the sort of the skills that you would need to write a program to, simulate a black hole or sort of stars, you could then apply to writing a climate simulation or simulating the atmosphere of the Earth. And a lot of the underlying physics will be the same. So with the Earth's atmosphere, you can do, you have to make a lot of assumptions, but you can do things like model it as sheets of air kind of moving over each other, and the equations which govern this behavior, you'll find in a lot of places like stars and things like this. So there's a lot of interdisciplinary overlap. And then with communication, I suppose it's the same thing. It's, although in this case, I'd argue it's more to do with data. And so communication is, one aspect, I suppose, is about handling huge amounts of data. If you're making a video call with your friend, right? There's got to be some way to encode all of the data on your end, send it securely through, either, a wired or wireless connection, and then to be able to retrieve it, disentangle it and everything. And in this kind of sense of data and, I guess kind of more abstractly data science, or that I guess applies more to the sort of the culture of communication itself. Again, if you work on projects in astrophysics, my main thesis really is that the topics you work on in astrophysics, even though they not might be directly related, I'm studying a star, this is not about a telephone, but the skills and the questions you kind of uncover during this process, and the skills and the techniques, things which you uncover during this process, can be applied to many other realms. So in this case, data, handling it, how to send it securely. I mean, the internet itself, it's not astrophysics, but the internet itself was first created by a bunch of physicists because they wanted to transfer data securely between different facilities in CERN, I believe. Might have to check me on that one. But it was created by physicists. And now the internet is, I think fair to say, an absolute staple of everyday life. So it's things like this, I'd say.
Got it. Thank you. Can astrophysicists contribute to international discussions on space sustainability? With this space race going on, how do you think they can contribute to the discussion?
Well, I think it's much in the same way, actually. So with space sustainability, the things I think about are, I guess, like kind of two main things. Firstly would be, how do you get the rocket up into space if you're building a satellite? How do you do this in a way which kind of minimizes the amount of carbon dioxide produced, which minimizes the cost and kind of the amount of water that goes into these things? Water sustainability is a huge part of it too. And so by understanding the environments of space, if we, the Earth's atmosphere, or I guess lack thereof atmosphere, the radiation coming from the sun and the different sort of temperatures and things like that. So for example, I know that in the Euclid telescope, which is a mission which recently launched, one of the huge problems they have is tiny temperature fluctuations in one of the main panels. Okay. And this is something about the environment of space. And, if this causes your telescope to break, that's not a very sustainable way to sort of to operate. So by understanding how space operates, we can sort of have more of an intelligent design to our rockets to make sure they work. And so we don't have to send another one. And then secondly, I would say it's about kind of debris in space itself. Because a big problem is once a satellite sort of finishes its lifespan, a lot of the time they just kind of get left up there. And so there's a lot of satellites which have no power, are kind of orbiting the Earth in a bit of a rogue fashion. We don't actually know where they are. We can kind of track them, but it's very tricky. And so again, I would argue this kind of falls into the sense of, if we better understand the environments of space, we better understand the impacts we have, which is, I would argue, a little bit more into kind of space science and astrophysics. But again, all these things are very multidisciplinary. We can hopefully make kind of more informed decisions to basically tidy up space. And hopefully, with research and papers that are published by astrophysicists, along with space scientists and engineers, help inform the decisions of, the people who can actually build these rockets and send them into space and operate them. That's my hope, at least.
Got it. How important do you think curiosity and independent learning are for students aiming to excel in life, at college, in studies overall? Oh,
I think it's the most important thing, actually. I think, of course, being a good student and, getting good marks, I'm not going to say that's not, it is important as well. But I'd say what kind of drives that is curiosity and independent learning. If you have, if you don't quite understand something, if you're not motivated to actually sort of, go away and learn this yourself, you might not quite understand the lesson, or you might be sort of sick one day or something like this, or it might just not been explained very well. If you don't have that curiosity, then I suppose it's a bit of a negative way of thinking about it, but it's having this curiosity, a more positive spin, encourages you to go beyond just what you learn, but also really understand what you've learned. And this is something which is not just about, getting a good, grade on your sort of exam report, right? This is something which you have to be fundamentally really interested in, and having that curiosity, because if you don't have any curiosity, then there's no sort of thinking. You don't think of these questions, right? You go, okay, well, I accept this. I know this is the answer, and then there's kind of, there's nothing further beyond that. So I would say it's the most important thing beyond being able to get good grades. My main takeaway that, if you don't think you're maybe clever enough or, or smart enough to do sort of things like physics or astrophysics, I'd say that's completely wrong. I genuinely believe there's no such thing as, oh, I'm not clever enough, I'm not smart enough. I was woefully underqualified for the PhD I got. And I'd like to think that it's because of my enthusiasm. Also, maybe he felt sorry for me, we'll see. But no, I think it is actually the most important thing, because skills can be learned, but a willingness to learn a skill is something which you have to come from yourself.
Got it. Thank you for the inspiring insight.
Thanks so much.
So what motivated you to pursue astrophysics at Oxford?
Of course. So, well, astrophysics, of course, is what I enjoy a lot. And specifically at Oxford, I think it's mostly kind of so 2 or 3 things. One, I suppose, is invariably it's the interesting sort of culture you get there outside of research itself. Of course, so firstly, I would say, of course, there's a huge interdisciplinary focus at Oxford. If you do sort of postgraduate research there, you get to be in the sort of world-class spot with many very kind of eminent professors in their fields. You get to talk with them in a very casual basis. There's not much of a hierarchy. It means you can just sort of knock on someone's door, go, hey, I want to sort of talk about this problem. And, as I always think, there's no such thing as a stupid question. I'm personally very good at asking stupid questions, but I don't think there's such thing as a stupid question. And so you can just go up to anyone, go, hey, just help me with this. And you meet so many kind of like-minded, creative, and sort of motivated sort of students to all, work together. In my office, that people talk around to, even though they're doing completely different projects, people can help each other. So it's firstly this. Secondly, I suppose it is kind of the professors themselves, right? And sort of the project was mostly the thing which drew me in. So my own supervisor, Professor Pedro Ferreira, basically was offering a project. I was really excited in this sort of project involving a field called numerical relativity, which is how we can simulate sort of Einstein's physics, Einstein's gravity, in very extreme environments such as the merger of black holes or neutron stars. And so having his kind of expertise and his sort of, his enthusiasm, and actually I had a second supervisor, Dr. Katie Clough, who is basically the expert on all of the software I use. I spent many, many hours breaking all of the code that she's painstakingly wrote. But it's about that kind of combined enthusiasm and the actual opportunity through the project they offered, this specific project, which kind of happened to be there, but through the sort of only available through the sort of the attraction of these fantastic sort of professors and minds, really. And then lastly, there's just the culture. It is a fun place. It's a very strange place, but overall it's very exciting. You get to kind of feel part of this kind of very old community. There's lots of really weird but fun traditions. Just go back thousands of years. You get to have lots of fun dinners. There's lots of societies. So, as you mentioned, I like doing silly theatre. If anyone likes Gilbert and Sullivan, then you'll know where I'm coming from. It's very silly. But there's opportunity to kind of enjoy life outside of just, like the office or the classroom. Everything is really walkable. You can go from a lecture to a cafe within 5 minutes. You can cycle as well, although don't get hit by the bikes. There's a lot of them out there.
That's good. Thank you.
Thank you so much for having me.